Welcome to the next episode of Ask the GrowBot. Per usual, I'm Jesse Porter with GrowGlide, Director of Cultivation and Content Creation, joined by Will Gonzalez, Director of Marketing and Creative Tech. And we have the luxury and honor this episode of being joined by Adrian Giovenco, CEO of Inspire Transpiration Solutions. I'll let him give a little intro, but at first I'm going to give him a little ego stroke. And I really do think Inspire provides the best integrated HVAC solution in the industry, HVACD, if you will. But in addition to that, it's not just the purpose-built solutions for cultivation and curing. It's the algorithms, it's the data cloud, the controls, it's sub-canopy airflow, understanding that there's integrations with, biofiltration and photocatalytic oxidation, and really understanding how to put environmental control in the hands of the cultivator to empower this industry to move forward. So in short, I really appreciate you coming on, Adrian. I'd love to turn it over to you so you give yourself a quick little hero intro so the audience knows who we're talking to.
Thanks, Jesse. Will, wonderful to be here. Great to see you guys. I don't know that I could have said it better myself, though. I really appreciate that intro. It's been a journey. We feel really lucky to have assimilated the knowledge that we have, really over the past, really 6 to 10 years. 10 years sort of got the little bit of start, and really over the last 6 years, almost 7 now, have just been focused solely really on cannabis cultivation, and how to optimize these environments, digging in deeply about the room dynamic, and the energy balance within these spaces. And that's really what it all comes down to. This is an energy balance within a sealed environment. And if we lose sight of that, I think that's probably one of the first big challenges that cultivators run into, where they're not able to balance the inputs and the outputs of that room. And ultimately yield suffers, quality suffers, consistency suffers, and your operational efficiencies of your facility suffer. And I think that's a lot of what we're seeing in the marketplace right now play out, and see, what have the ones that are successful done differently than the ones that are not successful. And in many of those cases, it ends up being the environment, where corners were cut early on in the design process or the installation process, or there was just lack of understanding or knowledge around system sizing and design and what those inputs really are, to be able to size a system for the right type of output, and how to go about it. So we're really thankful to be in this place. It's a challenge, it's a grind, as you guys know, as everybody in this industry knows, but we're really trying to help uplift the industry and bring forward the technologies that can take this industry forward for decades, and not just sort of limp through a couple of years here and there. And for us, that means working with the best manufacturers in the HVAC industry, and applying the appropriate data and control solution to the HVAC and environmental systems, so that everything is integrated together and you're able to get really good data to make your decisions off of.
Yeah, well put, man. I think, it's almost easy and intuitive to say you need solid environmental control to get better yield and manipulate phenotypic expression and really drive financial performance in this space. But I think there's a human cost too. When I think about my transition from a legacy cultivator to a commercial indoor cultivator, without control, you lose your job. You don't hit the numbers. And it's something that I spent 7 days a week in the garden growing. I didn't really have a chance to learn so many things you learned in your training in your career before you came to cannabis. And now that you're able to apply it, I think you're empowering cultivators to have job security, to grow their careers. And I think that brings me to the first question I want to ask the GrowBot, which is, in a single tier environment, I think there's a lot of shortcuts that you can take, right? You can dump air in the room, move it around in a semi-cyclonic action that relatively homogenizes leaf temp. You don't have these walls of multi-tier cultivation in the way. I think what I want to ask is exactly like, integrated HVAC, HVACD, why is that the best choice for multi-tier? because we hear so many different solutions from an environmental control perspective. And you and I have touched on this, right? We truly believe that HVACD is the best option for multi-tier indoor cannabis cultivation. I'm curious what the GrowBot has to say about it, and maybe we can unpack that a little bit.
All right, here we go. We queued up. So what I did is I asked ChatGPT to act as an expert in HVACD.
It knows what HVACD is.
Yeah.
Isn't that great?
You can prompt it to act like an expert in a specific field, so that it uses that context to provide some replies. So
should ask them who came up with that term.
Cite your sources, GrowBot.
Right.
That's a good one.
I think
follow up on that.
So obviously, right, like we have this optimal environmental control. I think energy efficiency, man, like I almost want to unpack the work of Brian Anderson, Mike Sartarian, and Jim Megerson in that recent study. Maybe that's something we get to a little bit later. I think for me, number 4 is the big one that jumps out, right? Understanding airflow. And when I think about quoting people for racking, one of my number 1 questions is, what's your supply return configuration? Yep. Where's the conditioned CO2 rich air coming into this room? How does it flow through the lights, through the plants, through the racks, and back towards the dehumidifier? And what does that air exchange cycle look like? To me, that's like number 1 reason why you should consider a single source, single brain, single ducting trunk. But I'd love to hear your perspective on it.
Yeah, I mean, I think that's really where we see the need for, in multi-tier, you need to be able to deliver the air exactly where you want it and return it from exactly where you want it. That's really the big benefit of a engineered system to it. There's 10 different ways to skin that and put an engineered system together, right? It's multiple air handlers ganged together into a single duct, or you have multiple supplies or multiple returns. I mean, there's a bunch of different ways to do that. And there are ways to just call it different levels and different types of systems that can get you that. But it really, I think the common denominator with all of that is that you need to be able to control where that supply air goes and where the return air comes from. The benefit of an integrated HVAC and dehumidification system there, the big benefit there on the airflow side is that you're delivering the temperature of air and condition of air to the locations that you want to, right? We're not delivering, some of the downsides of a non-integrated system is that your air conditioning unit is delivering 55 to 60 degree air, and your dehumidifiers are delivering 90 to 100 degrees air. Are either of those air temperature ranges the temperatures that you're looking for within, to be provided to your plant canopy? Really not, right? It's either too warm or too cold. And then you bring in mixing and getting CO2 in there. And you figure out, how do you mix those air streams together, right? You've got some heat from the lights at different locations through the room. And so it's like, okay, well, where are we delivering that cold air from the AC units and the hot air from the dehumidifiers to, in order to get that proper plant response, right? And so to me, that's one of the biggest differentiators with an integrated system, is that we're taking the air back in a warm, humid condition, cooling it down, and then reheating it back up before it goes to the plants, so that you're delivering it to the plant canopy within that parameter that you're looking for, right? Of, call it, 75 to 80 degrees, or 70 to 82 or 85, wherever, kind of wherever we're at in that wider range. But at least we're then delivering room neutral temperatures back to the plants. And oh, by the way, it can be CO2 rich, and it can have gone through air cleaners, like you mentioned, and other things. So there's other benefits and byproducts of it. But in a multi-tier scenario, you have no other way of doing that except with an engineered solution where you're delivering the right temperature and condition air to any of the tiers, and bringing it through the canopy.
And we fight about this all the time, right? Computational fluid dynamic modeling, like we'll yell at each other on whether or not the inputs were accurate and whether or not the model was correct. But the reality is that air flows like water. So if you have these different units delivering different conditioned air in different spaces, and we expect them to mix in an open air mixing plenum, what happens is we get these collisions of different temperatures and humidities, which create a dramatic delta between the top or the bottom or the front or the back of your canopy. And all of a sudden you're creating microclimates. So not just in one scenario, it's every scenario all day. You're just hoping that you're blowing enough air around. And if you really intend on blowing enough air around, the velocities are probably so high that you get stomatal closure and you lessen gas exchange anyway. So there's a compromise any way you look at it, unless you're really thinking about integrated. Now, I think some people say the knock on integrated is that it's too expensive, right? And maybe it's not as redundant. And I think that's where that recent study that I just mentioned with Brian Anderson, Mike Sartarian, and Jim Megerson, which we're all talking about in the industry, has reminded us what and how we really define efficiency and how we really define redundancy. And I think this is something that you and I talked about recently too, is like, what does success look like in this space, right? Is it adherence to set point within 1 degree or 1 percentage point of humidity? Or how do you define it, right? I guess everyone's got a different take on it. What is success? Is it the measurable outcomes with COAs and price per pound and yield numbers? That's where I'm at. Like, I'll take a little bit of a range and a little bit of a delta as long as I'm making my money. Whereas everyone's got a little bit of a different take on it, I think.
Yeah, absolutely. I mean, to me, that's what the business is after, right? Is about what are your costs on the input side and what are you able to sell it for on the output side, right? And are you just selling it that one time through, but you didn't get the optimal harvest out, you didn't cure it well, so that the customer experience wasn't the way that that they were expecting, and they're never going to come back and buy that a second time, right? So you might have got a high price point for it the first run, but if you're not focused on that consistency and be able to deliver that same product in a consistent basis for what the consumers are looking for, then you're not going to have that sell through and have the brand recognition that you'll be able to ultimately build with really strong consistency. So I think we see consistency and quality being the winners over quantity, right? Over just straight biomass creation, really, because that's what allows you to build a brand and build a higher price point, in what you're able to produce and really create separation.
Yeah, and I mean, speaking to redundancy, right, as a guy who ran mini splits and pocket DUs and package units for years, redundancy is every 2 years you rip them out and throw a new one in, right? So you get back to this base level of performance, which I think pulls us away from this long-term cost of ownership, where we'll touch on this a little bit, but I think it's a segue into PCO and other filtration methodologies that you can apply in duct, right? I feel like a lot of people that have been in business for around 2 years start to feel the sting of pathogen pressures, whether it's a reduction in yield or a reduction in quality expression or just more labor that they have to throw at the patient facility to make it manageable. Whereas historically, we would just gut the system and put a new one in. Now we're talking about maintaining the system over its intended lifespan, 10, 15, 20 years, whatever it might be, and making sure that we're delivering clean room air every single time. That's not doable if you have a bunch of disparate systems. You might have an air cleaning box in the space, but we've joked about this too. You're really not going to get all the air to that little box and allow it to clean. You need it to be in the ductwork. And if you have a bunch of mini splits on the walls, you don't really have a combined airflow system that you can filter.
No, yeah, absolutely. I mean, there's so many opportunities, I think, throughout to take advantage of systems that are engineered for the purpose. And the air cleanliness piece of it is definitely one of them, right? If we're bringing all the air through air handling unit or multiple air handling units per room, we're typically bringing that air through in a 20 to 30 air change per hour type of rate. And that means an entire air exchange in that room every 2 to 3 minutes, right? So every 2 to 3 minutes, you're bringing that air through the air cleaners that you have there in the space, and you don't then have to worry about other types of in-room type of systems like that, which we have not seen to be effective, really. Yeah, I mean, the redundancy piece is a really important one, and figuring out what that means to a cultivator and to the business itself, really, right? Is, I guess in different ways, there's different ways you can look at it, right? You can liken it to and say, okay, if I put one purpose-built system in there, yes, I'm banking on that unit being up, right, in order to make sure that I've got my condition. But what is, if you look at uptime on a piece of equipment like that, and you call it 95 to 99% of the hours of the year, there's going to be some downtime for maintenance or for repairs. And it's really, how do you mitigate that downtime and that maintenance? And when that happens, having the right type of alarms and controls in place to tell you when it's happening, to be able to go in remotely and troubleshoot systems and not have to roll a truck to fix we see about 50 to 60% of the truck rolls reduced with additional intelligence through the control system. And there's lots of different ways to look at it and to approach it that way. And there's many types of integrated systems that allow you to have multiple units running each room. We're starting to see a lot of larger scale facilities move towards hydronic systems, which would be a 4-pipe chiller boiler type setup. So a lot of different configurations of air-cooled chillers and water-cooled chillers and electrically driven chillers versus gas-driven chillers. They all really offer heat recovery in the form of hot water heat recovery off of the chillers, which make it really efficient. We have a lot of reheat to do in these spaces to get back to those conditions that we were talking about earlier, and not freezing out the plants and giving them that condition that they're looking for temperature wise. So if we can find ways to get free reheat effectively, that's really good for your bottom line overall. And so there's just lots of different ways, depending on the size and scale of the facility, to look at it. We view hydronic systems as one of the types of systems. While there is a higher first cost to it, it significantly reduces your potential failure points throughout, right? You make sure you have the right type of redundancy in the pumps and the right type of redundancy in the chiller and boiler plant, where you're generating that cold water and hot water. But you then have very few moving parts in the air handling units that are serving each space. And so there's really much less to fail. So there's lots of different ways to go about it. There's, having spare parts on the shelf with your technician to know what to do when something goes down, to minimize downtime. There's having roll-in systems or provisions for an extra, couple of dehumidifiers inside of a space. There's lots of different ways to kind of look at it. I don't think that you have to walk away and call it one or the other in this type of situation. I feel like the industry has kind of been set up that way quite a bit, where it's either going integrated or you're going non-integrated and more traditional. And I think that there's likely more of a middle ground than people realize.
Well, I think it's interesting when you unpack redundancy, right? We always think 2 is more redundant than 1. But when I think about cannabis cultivation, I think, how much time does it take me to get back to 100% of the performance value that I need, right? And we might have 2 units over here. That's 2 units. They're more redundant, but they both suck. So they're not giving me the performance I need. Whereas over here, I have 1 unit that's more capable. Sure, I have more vested in that, but I have better data collection. I know when it fails. I can see that and react immediately and get it back up to 100% much quicker than thinking these 2 units will never perform at the capacity that I need because I can't utilize them together and they fight against each other.
Yeah, that's exactly right. Yeah, I mean, it's a $1,000 repair on a piece of equipment that's going to last you 15 years versus having to spend 10 grand on replacing a dehumidifier altogether because it failed and you can't repair it, right? I mean, that's and all of the other downtime. I mean, we haven't talked about efficiency really as it pertains to this, right? And having all the in-room fans, all the fan motors around that are just inherently less efficient overall. And I think that's some of the study that you referenced that was just released. And I know that there's additional work being done to expand that study to a larger scale and to also compare DX systems with hydronic systems as well, which I really feel like is what the industry needs to start to see, and really, dive deeper into real life comparisons of these different systems.
This episode is brought to you by Slab Trays. Tired of trying to lift 4x8 tables every time you clean your room? Maybe that's why you don't clean the bottoms anymore. Tired of traditional plastic trays limiting airflow? Maybe that's what's keeping you from 85 grams a square foot. And we all know you're tired of the fire marshal telling you to put sprinklers in your racks. Don't sleep on GrowGlide slab trays. Easy to handle, easy to clean, they allow for better airflow and make every fire inspector smile. Hit up growglide.com today and grab some slab trays.
Let's unpack the efficiency thing a little bit more. Will, can you ask it a question about what is hot gas reheat relative to HVAC in CEA? The reason I ask this is that it's another buzzword, right? People throw around hot gas
relative
reheat.
to what? Gas reheat relative to?
Relative to HVACD in cannabis CEA.
Yeah.
The reason I ask that is that heat isn't cheap if you have to add it back. We can recycle a lot of the heat, and it's a big thing. It's a balance of efficiency versus performance, right? Do you want the heat you need, or do you want to not have the performance that you need? And I think that's something that I learned a lot with you, Adrian, was sizing these units, right? We know that latent load calculations are all over the place in the cannabis space, and we can unpack that almost on a different Ask the GrowBot. But I think hot gas reheat is something that cultivators throw around. It's a new terminology to a lot. They've been able to dive into it and start to understand this thermodynamic balance in the space. But I think you're probably one of the most gifted people in the space to talk about it. What does it really mean to utilize hot gas reheat? And maybe you can even unpack a little bit of the efficiency metrics relative to LED claims of, hey, reduce your HVAC by 70% by putting the drivers outside or using water-cooled lights in order to, I don't know, not need the heat. But speak to that.
We got a lot there. So first off, I'm pretty impressed by the knowledge of this bot here. It's been pretty darn strong so far. I think it's also important to know what search terms to kind of prompt them with and go into. But in general, in general, hot gas reheat is a technology that's been used for a long time in the HVAC industry, and it's effectively, when the compressors are running, instead of sending all of the heat and the refrigerant out to the condenser to be rejected, you divert it to a secondary coil. That's a heating coil inside of the unit. It's an additional coil. And there's a diverting valve, a hot gas reheat valve rather, diverting that so that you can take advantage of that heat basically, and use it as a first stage of reheat. That again is only available when the compressor that is connected or compressors that are connected to the hot gas reheat coil circuit are running. And that's really the biggest caveat I think that needs to be understood in the space, is that there are times, it's a very dynamic load profile that we handle within these spaces, right? You have lights on and a large dehumidification load is really the predominant load in the space when the lights are on. You also have some sensible load to take care of. And then what happens when the lights shut off? You have zero sensible load in the space. You actually have a negative sensible load because of the little bit of residual evaporative cooling that takes place from the plants. And now you still have a dehumidification load in the space during the lights off period. So hot gas reheat, during the lights on period, the compressor's running, you got to maintain temperature. You're getting that extra heat back as a first stage of heat. You typically don't need more heat in most scenarios during the day. when the lights shut off, we're now effectively false loading the compressor and telling it to continue to run, to cool down, to dehumidify, and then use the hot gas reheat that's connected to that cooling circuit to use as the first stage of reheat. It's typically not enough reheat in the nighttime period, so you need additional heat, either in the form of gas, natural gas, propane, or electric heat, which is predominantly what's used. You can also use hot water heat. Those are really the four options for additional reheat. You're always going to need some level of additional reheat, otherwise your rooms are going to be in the 60s. If you lose the hot gas reheat circuit, you've now lost another 10 to 15 degrees of reheat there, which means that you either needed to upsize your ancillary heat system higher, which is what we really generally advocate for, but it costs money. It's not free, right? And so this is all risk and reward and how you'd plan it all out, or you're just okay with losing about 10 degrees during that nighttime cycle typically. And I think the piece that is sort of the missing link in all of this and the assumptions that are made around this is that the unit manufacturer of this HVAC unit knows how to control it for this application and has the right sequence of operation embedded in that unit controller, has the right type of sensors in the space and collecting good data from the space to operate off of, but that then the unit is able to, knows what it's supposed to do. That's been the biggest stumbling block that we've seen throughout the entire industry with regard to units that have hot gas reheat in them. And one of the reasons why a lot of cultivators are unhappy with these units, even though they've been billed as purpose-built units for cannabis cultivation with hot gas reheat and all, right? The unit, whoever they bought this, whoever's manufacturing that unit and whoever's controlling it, literally writing the program and the sequence of operation on the unit controller on the HVAC unit, unfortunately just doesn't have the requisite knowledge of this space. And it's not a huge, I mean, the knock is not like saying, that it's really, I mean, it's a pretty new thing that we've all had to really learn ourselves, right? And figure out what is most important in that sequence and how it could be written and how it could be standardized around it. It's a lot of the work that we've put in over the last 6+ years is really deeply understanding that, so that we can, doesn't matter what the manufacturer is of the actual unit in the box, it means that we can figure out how to control it.
Yeah, and I think there's this, you bring up a great point about controls and accuracy of controls and being able to utilize this mechanical device to its utmost. But then there's also the cultivator, right? And I include myself in this, of not really understanding what was making me fail, right? I was always just blame the HVAC or blame the DHU. It's this, it's that. Why do we get powder and mildew? And the more you really dive into the science and apply the science and measure it through granular leaf data and start to understand that, I would say, well, I don't care, man. I don't need that extra heat. I'm not going to pay for the extra heat. And then you realize that every single time your lights go off, you have this 45-minute to an hour and a half period where it's the perfect opportunity for powdery mildew and botrytis to start to formulate and develop. And then we get back to the lights on period with the high humidity and it spreads around like crazy. That delta from lights on to lights off is what makes most cultivators fail. And if it happens every single day, it's 8% of the time you are cultivating in flower that you're in not just a danger zone, but a death zone where you're breeding fungus and pathogens. And I think more of that needs to be known, right? But the truth is, you might have implemented an SOP or a process that was a failure to start. And we talked about this with GrowLink and those guys too, right? Automation's important and controls are important. But if you automate and control the wrong way, you're guaranteed to fail consistently versus succeed. And it's a matter of understanding. I appreciate you unpacking some of that.
Yeah, no, absolutely. I mean, that transition period is one of the most important parts of this whole equation. And figuring out how to smooth those transition periods out is really key. And it's one of the reasons why we've taken our controls algorithm and sequence and applied it to controlling non-integrated systems as well, right? Because it's like, okay, we get it. It's a very cost-intensive, capital-intensive upgrade to swap out systems, and it may not always be available, especially in the current financial market really that the cannabis industry is in right now. But let's at least figure out how to control these systems better and get them, bring it, try to minimize those big spikes. We're not going to be able to fully remove them by any means. It takes an integrated system to really be able to do that. But we can take good light data, knowing and anticipating when those transitions are going to occur. We can implement different ramping sequences and things in that to help the systems. It's effectively almost tricking the systems a little bit into, putting them in different modes, even though the room isn't quite yet in that mode, but knowing where that's going to go, and anticipating it can help smooth it out pretty significantly.
Now, I know that you've had a lot of success recently driving into the retrofit market and applying your controls algorithms and cloud-based control techniques to, again, less sophisticated systems. I'm curious, when you visit a cultivation facility that's already been in operation, what does that process look like? I know as a consultant and an operator, I start here, I do some latent load calcs, I figure out what kind of performance I think I need, I figure out where the gaps are, I have to look at SOPs, I need to look at genetics. There's so many different things. And I know, talking to a few of your customers, you've had a lot of success in that space. I'm curious, what's your approach to solving for these problems that they might not even know they have?
Yeah, I think in general they know they have a problem in different
They just don't
ways.
know what it is.
They maybe don't, but they don't know why really. And so it's starting with what are the challenges that you're running into? Is it during, can you not maintain temperature, or can you not maintain relative humidity? Is it just during the day, or is it just during the night, or is it just in the first couple hours of the night? Kind of looking at that, and there's anecdotal information that you can get from cultivators in general. They'll know their rooms and what's going on day to day and day to night. But the best way to know that is to get really good monitoring data from it and get good granular minute by minute data from those spaces. So if they don't have that data, that's typically one of the first steps, is just to put in very, very simply, and it does not have to be very cost intensive, to just get some sensors in there, wire them up, plug it in and get some good data to go off of, or integrate into their existing control system and try to get, more frequent data out of it, right? Like a lot of the HVAC control systems that are out there are only giving you a data point every 15 minutes. A lot can happen in a cultivation room in 15 minutes, right? And so knowing what that is minute by minute is really one of the first places to start. But even outside of that, and them knowing that they have an issue and they're not able to maintain conditions, for us, that is always an energy balance equation.
Yeah,
right?
I think
so. It's like, what's your water in? What's your lights in? We run the calcs. Oh, and it's like, okay, you got this equipment there now. What conditions are you trying to maintain? We baseline that with the equipment that they have, and does it balance out? And if it doesn't balance out, now we know what we go to target, right? You're either under on sensible and cooling capacity, or you're under on dehumidification capacity. That's really effectively what we see almost across the board, is that you're under on dehumidification.
You lacked commissioning altogether, like number 2 points to here. Like system maintenance and inspection. Like 100%. Maybe your ductwork was I don't want to call anybody out, but you know what I'm talking about. Maybe your ductwork has a bunch of holes in it. You're not able to effectively deliver the CFMs that you thought you had. And you'll never be successful until you solve for that pinch point. So I think you made me painfully aware of this, of like commissioning, retro commissioning, system maintenance and inspection is such a real thing that as a historic cultivator, I don't want to pay for. Like, I'll just go hit my pocket dehu with a hammer when it doesn't work, or I'll go buy another one for $2,500, right? But these more sophisticated systems, it's really understanding how they're linked together and following things like, again, number 2, maintenance and inspection, number 3, calibration.
Yeah.
Simple concepts that are so paramount.
I would say, to me, it doesn't matter what type of system you bought, you should commission it and calibrate it, right? Calibrate it and commission it and make sure that what you put in there is working at least to the best of its ability, right? I mean, that to me, that's just coming from the commercial, industrial, construction industry. It doesn't matter what type of facility you're working on, it needs to be commissioned properly, right? And that, I'm so glad you brought that up, because you're 100% right. It's like, and I guess I would say it's not super often, but there are times when they have the right capacity on both sides of the equation and everything, but they're still having those challenges. And that is the first step, is to benchmark it and see, are you really getting the capacity out of it? Back to airflow, right? If you're short circuiting your airflow from the supply to the return, it's not going to where the load is in the room, right? And it's like, well, shit, we have the capacity, but we're just not getting that air, mixed well down into where the load is and back to the unit.
Right.
So there's
number 4 makes me laugh too, though. Like,
so many parts of that to unpack.
Yeah, when I think about data collection too, we talk about that. We're like, how do we make informed action plans? How do we allocate financial resources to solve the problem? I know you know where I'm going to go with this, but emissivity adjusted IR gun, right? You go buy an IR gun because you want to play with VPD and you want to know your leaf temperature. You run to Home Depot, it's 0.95 emissivity. You get some data, you're like, cool. Now I'm going to set my ambient at X, Y, and Z. And then you realize that you should have adjusted it to 0.97. There you go. Yeah. And it's 11 degrees different. That's 6 to 11 degrees on average different. Like, the accuracy of the data matters.
Yeah, you wouldn't have thought that it would be, by adjusting it by 0.02 emissivity that, you're going to be that far off temperature wise, but that you're 100% right. And making sure that you have the right tools to be able to make, understand what is really going on at the plant level. And that, you can because I think that sort of opens up the whole topic of VPD in general, which is just, I don't want to call it a buzzword because it's so important to, plant process and what we do.
But misunderstood.
But it's misunderstood in general between leaf VPD, which is truly what VPD is meant to be, and what most people use, which is air VPD, because there's not the connection to knowing exactly what that leaf temperature actually is without going through and shooting all, leaf by leaf and doing it in a really systematic way, right? It's not just like going and start, zapping around, right? It's like, how far away from the leaf am I going to be taking all of these readings, and at what interval through the canopy, and starting to figure out standard deviation, throughout that, and really putting it into a spreadsheet for you to fully understand what your entire canopy is looking like, because you're effectively needing to come up with an offset to, right now there isn't the ability to control the system off of like, a sensor box in the room that's taking, actual leaf temperature data, right? So we're still using air temperature. And so the closest that we've found to date presently, until we could get better sensing devices inside of the plant canopy, is systematically determining what that leaf temperature, air temperature offset is, and then being able to set that in the control system, and that's controlling the HVAC dehumidification system, so that when you're looking at the data and seeing VPD overlaid on your trend graphs, that's real leaf, real VPD, not air VPD.
This episode is brought to you by Inspire Transpiration Solutions. Inspire is committed to empowering cultivators with the best-in-class HVACD solutions. They drive plant vitality with cloud-based controls, in-duct biological filtration, and sub-canopy airflow solutions. Whether you're building a precision-controlled flower room, large-scale curing space, or retrofitting your existing facility, Inspire is a trusted partner to help you use purpose-built environmental control to reduce risk and optimize phenotypic expression. Reach out at inspire.ag and get your environment under control today.
And when we really talk about crop steering, another buzzword, right? It's only possible with environmental control and how you utilize that environmental control. And I love the topic of VPD because it really helps you unpack a lot of different tools in the space that help you cultivate better cannabis. And, you know, it's PPFD, it's distance from the light, it's top of the canopy, bottom of the canopy, it's plant morphology, it's cultural control, it's laminar airflow, it's the ability to get that conditioned CO2 rich air whipping across the plant leaf surface at the appropriate velocities. All these things matter. So like we just said, you might go in and measure once, but once isn't enough. Now, once you measure a bunch of times through enough runs, you get a pretty good average and know where you're at on a week-to-week basis. But that's what I joke about too, is that you might slay week 1, 78-degree leaf temperature, everything's humming, your HVAC's as efficient as it possibly can be, and then they grow closer and closer to the light. And then you want to yak it out a little bit, so you go up to 12, 13, 1400 ppfd. Then what happens? Your leaf temperature climbs. You need more cooling. You need more airflow. And are you considering all those things? Are you recalibrating your gun? Are you checking it again, you know?
Yeah, that's super important all the way through. I mean, the PPFD item is really interesting because you know, when you start to push, I don't know that there's enough data out there to really definitively say what is push, you know, at what level of pushing PPFD higher and higher is your plant process, you know, effective to the point that you're bringing in needing to draw a whole lot more water through, and you're now out of balance again from this equation, you know, that we're trying to figure out inside of these spaces, because you've now, you know, is it linear, and is 1500 ppfd compared to 1000 ppfd, you know, the same comparison and linear relationship to watering rate?
Ask it about business efficiency, right? Like this is what Adrian's getting at, right? Asking about PPFD relative in cultivation relative to business profitability, because that's what we're talking about, right? Like, do we chase 1400 ppfd and 1800 parts per million CO2, bring in the sensible cooling we need, plus the latent load that might jump from 0.25 gallons per canopy square foot to 0.33? Where do we hit the point of limited returns where we're only getting 5 more grams per square foot for an increased cost of production of $300, $400, $500 more per pound relative to labor and energy and all these other things? I love chasing more. You know me, I'll push the envelope, I'll hit the gas pedal, but there's also a moment where I got to feed my kids. And if I'm cutting into my profit margins, I'm not getting better COAs, I'm not getting better price per pound, and it's costing me more to produce and it's less efficient, it becomes a balance.
Yeah. Well, and the capital cost, I mean, everything that we see today is that there is a pretty linear relationship between that PPFD and the watering rate ultimately, and then there's a continuing linear relationship with the amount of HVAC and dehumidification equipment it takes to remove that moisture and the cost of that overall system, right? So, you know, you're just ratcheting up the capital cost of that facility to do it that way. And I think it's a wonderful question to ask. I'd love to see.
Nothing pisses me off more than number 4, right? Dimming my lights. Like, so what you're telling me is I made the wrong lighting choice and I have to dumb down my lights in order to fit within the performance parameters that I couldn't afford to optimize before. Now I'll never know what this light is really capable of because I have to dim. And I get it. There's different strategies for senescence and transition from veg to flower and things like that. But I hate the idea of dimming a light. I bought that photon. I'm going to run it as hard and hot as I can. And I want everything else to keep up. Otherwise, I'll never know.
for sure. So yeah, I don't see any. Is that the bottom of it right there? I don't see anything in there talking about. I mean, do we have any? We have.
No, we can ask follow-up
Targets,
questions. It basically
lighting.
was really relating it to lighting, right? So I asked, tell me about
So
PFD
I guess
cultivation.
it's maybe. So how does transpiration
How does
or
PPFD information and
How does transpiration factor into this?
And I think that's something we're all trying to figure out as an industry, right? Because we can't find this linear correlation to 1200 ppfd equals this much transpiration rate, or 1300 equals this. There's a lot of anecdotal data. Then there's people that are successful based on their brand recognition, hype, or genetics that are allowed to be financially viable despite their lack of granular data collection associated to the relationship between those things. And that becomes frustrating across the board, right? Who do we really listen to? Who do we trust? There's so many different ways to find financial viability in here. We're trying to tie it back to science, and there's just not enough good data. Maybe because there's not enough good control. Back to your point on, having the right algorithms for HVAC control.
Yeah, so the question was, how does transpiration factor into this related to PPFD? So that's kind of the follow-up question there. So we have increased photosynthesis, PPFD levels increase, water and nutrient uptake, temperature regulation, humidity control, etc. What's you guys' take on this? Is this an adequate response? Is this how you would look at it?
Well, I mean, I think we have to understand this relationship. We have to unpack it. Increase photosynthetic energy, increase photosynthesis, right? More water and nutrient uptake. This is true, right? Temperature regulation, more transpiration so it can cool itself, just like sweating outside in the breeze. And then it just says humidity control. And this is one, Adrian sort of taught me this, I'll be honest, right? It takes twice as much energy to dehumidify as it does to cool. So in the end, I would rather cool than dehumidify. So when I think about some additional heat brought on by this light, I'm not quite so concerned. I know that there's some tricks of the trade and also just some efficiency metrics in my favor to be able to cool the room and get to the right leaf temperature relative to ambient. But I don't really know what the relationship is to humidity and how much more humidity I'm going to get in the space, and whether or not I'll even be able to reach that with the mechanical solutions I have. And that's the biggest fear when we talk about facility design. No one really knows what to tell you from a latent load perspective at 1500 ppfd.
Right. Yeah, I mean, I think, and what this tells me, and I think this is what we would agree with, is that it's increased. And that what to what, right? And so that's then, it needs to be increased. Is it 10%, 20%, 50%? I think those are those real specifics are to be determined still, but it's clear that you need more. You're going to have more moisture to remove in that space.
Can we ask the GrowBot a loaded question?
Sure, let's hear
what is the transpiration rate of cannabis at 1100 ppfd?
Oh, there you go.
That's something that a lot of people in this industry relatively closely agree on.
All right.
Yeah.
Let's go. I like it. It's not a fixed value.
Yeah, but it's 0.25 gallons per canopy square foot, right? Like that. That's the number we all throw around. And this is great, right? This is
3 to 5.
Okay.
3, what is that?
Yeah, right here.
Micromoles.
And now we got to do some unit conversions here.
What do you want to convert
Dude, it calls out optimal temperature. It just says optimal ambient temperature.
75 to
optimal leaf temperature, but
85, right?
And CO2 up to 1500. This is, an interesting answer.
It's all pretty good. I don't have the 3 to 5 micromole of water per
Have GrowBot convert it. What's 3 to 5 micromoles of H2O
in my head
squared per second?
What do you want to convert it to?
Gallons per I mean,
Canopy square foot.
ultimately gallons per day. I mean, you could say pounds per hour. That we size the systems themselves are sized in pounds per hour.
Tells you how to convert it.
Wow.
Convert it to moles, convert moles. So it's going through the whole process. It's going to give you the
All
answer.
right, there you go.
It's going to show the work, basically.
Man,
Liters.
college just got so much easier for my kids. I tell you what.
Yeah, it's pretty pretty controversial. There's a lot of colleges that flat out like ban ChatGPT. Schools and college universities, they have
Sounds like a
tools.
shitty college.
You can get paper. Teachers can run a paper through another AI and determine and detect whether it was generated by a human or AI. So, like, students are screwed because if they use ChatGPT, they're going to get caught. Basically.
That's what I was gonna say. It's actually, I don't think it makes it easier. I think it makes it harder.
Yeah. Yeah.
All that math. All that
All
math.
that math, dude.
Just to get to point.
Corresponds with maximally 1.23 to 2.06 gallons of water per square meter.
Now you got to go. We got to go from meter to square meter.
You just divide by 9 on that per square meter.
All right. So what do we got?
I think you divide by like 10, right? So it would be.
So it's
0.123. 0.123. What do you think the answer should be, though?
I mean, we see it in general around. We talk about 0.25, which is roughly a liter per square foot per day. This is,
and that speaks to the energy water balance, right? Like that
0.23.
speaks to the scientific optimized max, assuming we have the right airflow and right CO2. I think, Adrian, we agree. We've seen lower in situations where the plants haven't been as healthy, anywhere from 0.2 to 0.25 in a 1100 to 1000 ppfd range.
I mean, there's variables in here, right? There's a lot of variables. It's, you know, and to me, it's in general like around total plant canopy. You know, like how tall the plants are has an impact. You know, you're gonna have, I don't know, that there's a number of variables in there, and I think it can be
leaf area index. How many leaves are on the plant? How dense is that, right? Like, what is the top of the canopy? Maybe the top of the canopy sees 1100, bottom sees 800.
Yep.
There's a different rates.
Right. So the conversion was 0.114 to 0.19 gallons of water per square foot per day.
Yeah, I just got was dividing by 9, and it's 0.13 to 0.22.
Yeah.
So, you know, we're talking about 2.26 sort of as an average to use, which, you know, to me, if we're going to take a range that's, you know, that's directly the science, you know, like a mathematical type calculation range, you probably go a little higher than that. But that's, you know, we've modeled over 2,500 rooms. There you go. That's a real good resource. What does that book say?
Yeah, I think this one's right around 0.25, 0.24, 0.26, that range.
Yeah. I mean, I think it's, you know, out of all the rooms we've modeled, like I said, we've modeled like over 2,500 rooms. And the average, that's really in general, the average that we see is somewhere between 0.22 and 0.30. And so in general, that's kind of a go-to type of industry standard, especially when you're designing for multi-tier, because you're going to assume that the plants are not quite as large. You're going to have shorter plants and
so there's some context that ChatGPT is clearly missing. So that's where, you know, you got experts on here that kind of have that real life experience and understand multi-tier. So it makes a difference in knowing that context.
That's pretty darn close. Where did we start there with that? That was 1,000 to 1,500. Like where we
1,100
started. That was 1,100. Got it. Okay.
Yeah. So we started.
So, I mean, so what? Ask them 1,500 now.
Oh yeah. So.
Or 1,800.
Okay. 1,800. Let's do 1,800.
Let's do 1,800.
No, 1,500.
I'm
Stop.
just gonna say,
do something sort of real at least.
Don't show your work.
Yeah, there you go.
Provide final answer.
Final. It's going to put me out of job with this.
Final answer in square feet. Yeah, in gallons per day per square foot.
Per day per square feet. All right, let's see.
So much for your psychrometrics chart, man.
Yeah, we don't need that either.
There you go, 0.23 to 0.3. Don't show your work. That's good. We saved some time there.
Another tool that I won't need, Adrian.
There you go, in the trash can.
0.23 to 0.36.
Hey, still got that psychrometric chart hanging around. I like it. 0.23 to 0.36. Okay, I mean, so that's, and that was, sorry, that was 1800.
That's a huge range.
It's a big range. It's a big range for sure.
Like 50 to 100 tons difference.
Yeah, it's like a 50%. Range there.
Yeah, it'd be like from 50 to 75 or something. Or,
yeah.
I know we're clawing up on time here, Age. I don't want to keep you longer. I'm down to do this forever with you, man. I appreciate you coming on. Is there anything else you wanted to throw at this GrowBot, or anything else you wanted to add?
I mean, what other
value propositions?
What other stuff do you guys have coming up often that, I mean, I guess we talked about airflow, right? And delivering the air to where we want it and returning it from where we want it.
What do you mean unclear? Who
coined the term?
I asked it the same one when I was messing around with it, and it came up with it. It said the same thing. It was hilarious.
I should have listened to you, Adrian, when you said we should copyright it when it first came out of my head.
Man. Yeah. I asked the same thing. It's like, it said like, yeah, it was like, you know, it was pretty funny. I think it was very similar.
So when your approach to like
who came up with it? No single person who can be credited with coming up with the term HVACD is what it did.
Yeah.
Too bad, buddy. Too bad.
You have to TM.
I'm just giving it all away for free, brother.
That's right. That's right.
So one thing that came to mind as you guys were talking, so Adrian, when you approach cultivators and you're talking about, you know, HVACD systems, like what are like the top 5 things for, you know, for these cultivators to know and what's important, and kind of like in layman's terms, because we're getting into a lot of technical and, you know, aspects here in science, but in kind of layman's terms, these are the top 3-5 things that are really important and you should never ignore, right?
Yeah, I mean, you know, number one for me, I think always is probably going to be sizing, understanding your right size, to be more succinct, right sizing your system, your HVAC and dehumidification system. No matter what type of system you end up with, right size it, right? Understand.
Canopy relative to PPFD are the 2 most important factors in allowing you to effectively size a system, Adrian?
I mean, I think high level it is, but that it's, as far as the inputs that we need to know, is temperature, relative humidity of the room that you want to maintain at the coincident largest watering rate. So your highest watering rate that you're going to look to maintain, which we typically ask for in the week 6 to 7 range, as far as kind of like maximum plant, you know, process. And then the corresponding temperature and relative humidity that you want to maintain at that given time. Those are the most impactful items and that are directly related to the overall system sizing. So when you try to right size it, it's knowing really what your watering rate is and knowing specifically what temperature, really the highest that you feel comfortable pushing your temperature and relative humidity to at that coincident watering rate is going to help you optimize your system size and your system cost. Going low and going, I need to get to 70-50 at a watering rate that you're inflating because you've never really been able to get there, is blowing up your system sizing and budget on both sides, really, by going too low and overestimating the water that you need to remove. So knowing
it was
those,
amazing to me. 5 degrees, just a 5-degree difference in set point change that you submit to your HVAC provider can dramatically alter the performance need that they recommend to the tune of a ton of money. I'm really glad you brought that up, and that's actually one of the answers to one of the items you brought up earlier that we didn't hit on, which was, you know, like as in an HPS to LED conversion type of situation, or, you know, what is,
what is the impact on the environmental control system? It all comes down to what that given piece of equipment can do. And in order to know what the capacity is of that piece of equipment, you have to know what the conditions are of the space that you're looking to maintain, right? Air at a warmer temperature and a higher humidity can hold more moisture than it can at a lower temperature and lower humidity. And so that given piece of equipment can do more work and remove more moisture and more water out of that space at a higher temperature and relative humidity combination than it can at a lower one. So you want to be able to push it as high as possible within reason and within comfort zone. And you also want to recognize that in an LED environment, there's so much less heat in that space, infrared heat in particular, that you want to run that room warmer than you did in your HPS environment. I think it's a misnomer in the industry around why you end up needing less HVAC and dehumidification equipment with an LED space than you do an HPS space. Yes, there's less sensible heat in the room, right? It's a 700 watt bulb compared to a 1,000 watt bulb. That's pretty straightforward math, right? You just convert that to BTUs and to tons of system. That's only one side of the equation. That's only the sensible heat, the temperature, the feel of the room temperature that we feel. We've completely missed out on the latent heat and the moisture removal component of that, of which the energy into that room is the water that's going into the plants, right? And so being able to increase the temperature of that room to 82 to 85 degrees, that is what gives you more capacity out of that given unit that you're using, and why it effectively feels like you need less HVAC equipment for that LED room than you do the HPS room.
Can you clarify before we get out of here? So, maybe we cut this, I'm not sure. I hear a lot of talk from LED providers, and I know everyone has their own value proposition. I'm not here to knock that. I have a lot of respect for the different lights in the industry, but there's water-cooled lights. There are lights that put their drivers outside of the room. Can you maybe speak to those two different solutions and how they would impact the performance or the performance need of an HVAC system?
Yeah. I'm going to completely stay out of anything around the lighting technology and all of that. That's just not what we do.
I'm just thinking
right?
heat.
Yeah, absolutely. I just want to kind of be clear. Like, we'll let all the different LED companies go at each other.
Yeah.
On spectrum and PPFD and kind of all these, all this different kind of stuff. Sure. As it pertains to the HVAC system, it really just has to do with the amount of heat that's inside of the space. So if we have the drivers inside the space or outside of the space compared to inside, how much heat are those drivers generating? And then you just take that heat out of the equation, right? Sure, that's something that we see done, really not that often, to be honest. It's, what is it, 10 to 15% maybe of the total heat is the driver heat. And so is it worth it for whatever additional it's going to cost you to remove that 10 to 15% of heat out of there? If it is, okay, no problem. In general, like we talked about, we need the heat in the room though. And so whether it's the heat from the driver or if it's the sensible heat that you're removing with a water-cooled LED type light setup, I'll let the LED manufacturers kind of go at it to each other as to whether they can develop a better a better light source for the plants around that, and whether if that's impacted with water-cooled versus air-cooled lights. Just in general, we need the heat in the room, so we're going to need to reheat that space back up. And to me, I would look at it as an overall cost-benefit analysis for your entire facility more than anything, right? If you're not integrating those water-cooled lights into a water-cooled HVAC system, HVAC and dehumidification system, of which there are great options to be able to take advantage of that, and you're piggybacking the installation cost of all of that water piping in together with the rest of the water piping that you're already running through the facility. To me, that's one of the only places where I think it would make sense and pencil out. If you're running water piping throughout your whole facility just for your lights, and then to a separate cooling tower, and making sure that system's always
separate
up online and running. Well, it's just a cooling tower. It's just you're just rejecting the heat to a two-pipe system, to like a condenser water loop in that situation. Unless you've got a more complicated scenario together. There's difference in, there's a couple different systems that we've seen out in the marketplace. And I guess I would love to see them pencil out if they really do. I'd love to get more information about them. I just have not seen it pencil out to date.
Mm-hmm.
Dude, Age, I appreciate you coming on, man. And I think for another episode of GrowBot in the books, this is a good one, right? We covered a bunch of topics. We leaned into your expertise. You touched a little bit on conventional, non-integrated, integrated, single tier versus double tier, operational efficiency, hydronic systems, the future of sizing, understanding the inputs, understanding how to use the tools around us, the importance of controls, especially if we're going to use VPD, the importance of commissioning, the importance of accurate data in this decision-making process. And I think we also expose the fact that we don't have all the answers, and that part of this business is a little bit of experimentation, especially if you're going to push through high PPFD and some of these newer technologies that might have an upside. They might also have unforeseen obstacles that we need to overcome along the way. I appreciate having you as a resource to be able to lean into. And I know that the industry does as well, being able to reach out to inspire and find solutions for integrated HVAC problems, but also for retrofit and just understanding how to understand the efficiency of their facility as a whole.
I really appreciate being on, and you couldn't have said it better. That's what we're all in this for. And if we all had the answers, I think it'd be a heck of a lot easier. This industry is, in general, we're in so many different ways building the plane while we're well up in the air in mid-flight, right? And so it's figuring out how to manage your risk, really, and manage unknowns, and make sure that that you're not putting yourself at undue risk, really, for no upside. And just in practice, like the benefit of airflow, right? Getting better airflow and better data, right? Those are, you asked about the top 5 things. Those are the other 2 that I would throw on there, right? Good airflow and good data to be able to make decisions around end up being really valuable almost to every single grow room that we walk into.
Fantastic.
Awesome, man.
So enjoy it, guys. Thank you so much.